Welcome back, Hampshire chemistry students. In this video, we're going to be taking a look at a little bit of intro on how we can discuss the topic of rates of reactions. So, the goal of today's video is that I can describe what will increase or decrease the rate of a chemical reaction. And chemists are really interested in what makes chemical reactions go quicker or slower, because oftentimes they're trying to sell the things that they're making, or maybe those things will help people. So right now, a bunch of scientists are currently trying to manipulate the rates at which they can make things for different types of antiviral medicines or vaccines. So these are huge topics in chemistry. But before we get into some of those factors that can increase or decrease things, we kind of need to understand what it means to go through a chemical reaction and what's needed. I'm going to represent my chemical reaction with my little pieces of Tupperware here. You can use a lot of different things, anything that snaps together, like Legos or a bunch of stuff. So, in order for my Tupperware to react, to become together, there has to be a few things that have to happen, right? They can't just magically smoosh together from across the room here, right? They need to come together. Oh, that didn't work so well. So they don't just need to come together. They don't just need to smoosh together. They need to come together in a correct direction, or sometimes the word is going to be used orientation. Orientation means like direction. So we're going to put these two in the correct direction. Oh, hey, look, they kind of snap together there, right? But there's one last piece that needs to be included here. We need to not just have them come together. They don't just need to collide. They don't just need to be in the same orientation. We also need a little bit of energy. Some kind of force to pull these two pieces together. Now, we can have lots of different types of reactions like this. Like I've got a different set of Tupperware here. These guys will also need an orientation, but look, the energy is a little bit different. Sometimes reactions will be different depending on the different types of chemicals. So, what do we need in order for reaction to take place? You need three major things. Those are the collisions, that orientation, and energy. And if you don't have all three of these things, no chemical reaction can take place. But let's say now, I want to speed up this reaction. There's a couple different things you can do. The first thing you can do is you can start to get your particles not to move, not like at a snail's pace, but to come together quickly. We describe that idea of energy movement, right, as temperature. That when we have molecules that are at a low temperature, those molecules are moving slowly. So they will come together eventually, but not very fast. But faster molecules that are moving that are very hot, will come together quickly and react quickly. So higher temps creates faster movements, creates faster reactions. Now, there's other things that can affect different types of reactions as well. The next one being a term called surface area. Unfortunately, I don't have a great representation with my Tupperware for this, but surface area just kind of means how much space there is on the outside of something. So something that has a box like this, where there's just four sides, has a low surface area. But if I break up that same amount of space into four different pieces, we now have a much higher surface area. I like to think about this when I cook. I could just take one giant piece of, I could take a whole frozen chicken, boom, and throw it in the oven. That's going to take hours. Or I could just bust out the chicken nuggets out of my freezer, and those little pieces of chicken that have higher surface area than my big piece of chicken will cook a lot faster. So when I see a high surface area, that tells me there's more space for reactions. In the case of the cooking, there's more space for food to get in between, right? Think about your microwave. You want to microwave little pieces of things, not one giant thing. That leaves more room for all that energy to get in there. Either way, more surface area, more space equals more reactions. So, our next we have two more different types of things we could talk about here that will change your rate of reaction. The next one is concentration. Okay? We talked about concentration a lot with the idea of molarity. Okay? When I have a low concentration and I want to have two things find each other, they may eventually find each other, but they will take a long, long time. Remember, they're going to be moving around. But when there is a high concentration, there's going to be a lot of space for things to move around. Okay? And then this guy can find a partner much, much easier. And then, so we know that high concentration means more chances to react. And that means, again, faster reactions. So, very finally here, we have the idea of something else that can increase the rate of a reaction. And that is called a catalyst. Okay? Catalysts are a type of chemical that essentially just make it easier for other chemicals to react. In biology, you might have called these enzymes. Okay? Their job is to take energy of a reaction. So, hey, you might remember some of these graphs when we talked about endo and exothermic. This would be an example of an endothermic graph because we have energy increasing over time. But what we see here is we have this weird like bumpity bump in the middle. Okay, that is called the activation energy. That is the amount of energy it takes to activate a chemical reaction. The bigger this is, usually the slower the reaction takes. It's like if I have to start a big old pickup truck or a semi truck, those need lots of activation energy to get their big motors spinning. Whereas if I have a catalyst, my activation energy is much lower. Something with lower activation energy might be like a bike. Hey, I can get a bike started a lot easier than we can a semi truck. So, by adding a catalyst, you lower your activation energy, which again means faster reaction times. And what you guys are going to be taking a look at in the next couple of days is some different things that we can focus on for those different types of rates of reactions. And today you're going to be reading an article about how the surface area can be very important when you're dealing with storing different types of materials, and how something like a piece of sugar, like in a marshmallow, could actually become explosive depending on its surface area. So you're going to be taking a look at all these main things, okay? Just one more time so you can have them all up there again. Those were catalysts, temperatures, concentration, and the one you're going to be focusing on in the article, surface area. Okay? Thank you guys so much for watching, and I'll see you guys coming up soon. Have a great rest of your day.